Hello, everybody. This is Fundamentals of Chemistry and Nuclear Chemistry. And we're starting today with the Fundamentals of Chemistry. So we're going to be talking about two areas we're going to be going over today: components of an atom, the basic structure of an atom, and the periodic table arrangement. So let's go to the next slide now. We know the basic components of an atom: the neutron, proton, electron. And on this next slide here, as you can see, we have an atom, which is a and what we're basically looking at is neutrons, protons, and electrons. And with this shaded arrow that I have there, I'm pointing out where a neutron is located. As you can see, this neutron is located in the nucleus of an atom. And in this nucleus, this neutron has a zero charge, no negative or positive charge, none at all. That's what we call it, neutral, no charge. And also, as you'll know, I noticed on this next slide, pointing out the proton. The proton has a positive charge. Okay? Protons are positive, starts with a P, the easy way to remember it. It's also found in the nucleus. And you also notice that in the nucleus, the neutron and proton are together. This is where the mass of an atom, most of its mass is found. And we usually call this the atomic mass. It's protons plus neutrons equals atomic mass. And usually, we'll see here in a little bit, you see a large number of radiation that represents the atomic mass of an atom. Okay, on this next slide here, we have in yellow here, the yellow arrow, we're pointing to the electrons. And electrons, they are in they're subatomic particles, just like the neutron and protons are, which make up the atom. And as you notice that the electron is actually circling or orbiting the nucleus somewhere on the outskirts around this nucleus. And when it's happening, there's a gravitational field in the nucleus, kind of keeping the electrons orbiting around the nucleus like a satellite flying around the Earth. The next slide is talking about the periodic table, how the atoms in relation to the parts of the atoms, how they relate to the periodic table, and they're actually three groups in the periodic table. And we call this period groups and classifications or classes. As you can see here, this is the first periodic table made by Dmitri Mendeleev in 1869. It's kind of very rude, crude one that is made up. It's made up of approximately 71 known elements at that time, or atoms at the time. And as you can see also along with it, that there are some blank spots. And these blank spots were actually used for future atoms that were being discovered. And as you notice on here, there's some question marks on some of these. These are probably questions on if that was the right element or not being made. But we do now have 114 elements that are listed in the new periodic table. And this next slide here on the periodic table, as you can see, is a lot different than the one that was made by Dmitri Mendeleev. And this has evolved over the years with many scientists' input in our present day periodic table that we have. As you can see, the key shows how each element is arranged by characteristics. There's also a color code key at the top. Bluish areas are semi-metals or metalloids. Greenish to bluish areas are intermediate gases. As you can look, there's information in each box. It has its atomic mass, state of matter, atomic number, etc. You can put all kinds of information in. You can notice on the top of the columns are numbered from left to right, 1 through 18. Columns 1 and 2, 13 through 18 are representative. And columns 3 through 12 are transition elements. The bottom ones, which are purple, are called the intertransition elements. And this is the basic of the periodic table at this time. You also notice between elements 112 and 114, some spaces there for future elements as well. And also, some of these that are triple letters, they have been discovered, but haven't been yet officially put into the periodic table. So these are kind of like pending, ready to go. On our next slide, we have the periodic table. I have an arrow on the left-hand side is the periods. And you notice that the periods rows 1 through 7, okay, and they go from numerical order from left to right. And as you notice also, as you go across, the number increases by 1. And what's happening, we're adding 1 proton and an electron also, and it's changing the atom into a new element. Um, it's also important to notice that we have 7 rows on the left-hand side of the and, and I'll bring this up a little later about how that's electron when I get to the electrons. And this one I have the blue arrow pointing at the top of nitrogen. We call those groups. And on this slide, we'll be looking at columns and how the atoms are arranged. We have 18 columns, which are mentioned in our earlier slides. Each columns or groups of columns have specific names. For example, like column 1 on the far left-hand side is called the alkali metals. They are very reactive metals. And as you go down the column, it's kind of like a family tree that has characteristics that's common. One of those characteristics is valence electrons, was I mentioned earlier when we talked about periods. And when we get to the valence electrons slide, that's kind of more about the later. And group 18 is another example. They're called the inert noble gases. And it's on the far right hand side. And we have some other columns in there. We have group 13, it's called the boron family. Group 14 is the carbon family. Group 15 is the nitrogen family. 16 is the oxygen family. And number 17 is called pellets, which is sulfates, which is group 17. And that's the name of it. And as you notice here, I've actually broken down into 3 classes. And with the red arrow, those are non-metals. And in the blue, kind of like scatter step, semi-metals. And then the ones that are blank, those are metals. Now, when we talk about metals, I'll give you some information about that. Metals usually carry characteristics. They are metals, that heat, electricity. Semi-metals or metal is the stair step. That's the characteristics of metals and non-metals. And you usually find these as semiconductors, like excellent circuits that don't like the still conduct electricity. And then your non-metals are metals that don't conduct electricity or heat. As an example, in the far right, you have some are gases. In the column 18, they're all gases. Our next slide will be about valence electrons. Now, this here, this is an example of a diagram of how the electrons are put in, arranged around a nucleus of matter. Basically, groups are elements that have the same kind of electron arrangement. The other electrons are called valence electrons because they have the same number of valence electrons. Elements in a group share similar properties. The Roman numerals of each group are usually the number of valence electrons. If you go back and look at the periodic table, I'll go back a slide here. Right next to the group number, there are these Roman numerals. And those Roman numerals represent how many electrons are in the outer level. As an example, you can see on this one, we have 1 electron in the outer shell level. You count how many of these energy levels surround surrounding this nucleus, we have four. So row 4, okay, and you go to column 11, we're talking about the copper, the element copper. Everybody in that group, in group 11, you go down there, every one of them has one extra electron in that family. You go right down to row 5 and row 11, that one extra electron. Okay, if you look at this diagram, it's around the nucleus. Depending on which row you're on, it will tell you how many energy levels around the nucleus. For example, if I go to row 7, how many atoms to go across there? All of those will have 7 energy levels. And depending on which column they're in, number of those electrons. If I go to row 2, here, each one of those elements on the cross will have 2 energy levels. So it's a real quick way. You have to draw a diagram of the atom. It's best parts of each on the atom. You draw the best parts of that atom, say, top list, 4 energy levels around it. And you can have how many electrons on each level. And that's the last one would be your best electron. So that's what it's kind of in a nutshell. It's kind of the characteristics of an atom and the